Today's video is a brief one about an introduction to antenna tuning units, why we need them. We're going to cover VSWR, just a simple explanation, the setup at this QTH. So the setup I have here at home in terms of radio and antenna, and a quick demonstration here. Let's cut to it. So here are a sample of different antenna tuning units. The ones I use are in the middle row, strangely enough, one right on the left, one right on the right. The one on the left, the silver one, the 971, I use for outdoors, mobile kiting, things like that, and the black one on the right, which is a 941E, I use in here in the shack. So there's a sample of all the different ones available. There are many, many more. So you ask yourself, why do I need an ATU? Well, it's quite simple. It's all about impedance, and the radio transmitter on the right here has an impedance of 50 ohms, and you need to match that to an unknown impedance on the left where your antenna is. So the antenna I've just left blank here. It could be a piece of wire, it could be a piece of rod, whatever. It could be a vertical, anything. But as you vary the frequency, the impedance will change because it's only resonant on the one frequency. So the name of the game here is to match the unknown using the antenna tuner in the middle to the 50 ohm that the radio expects. If you don't do that, there will be a mismatch, and say you're transmitting 100 watts from the radio, it goes through the system to the antenna, and a certain amount is reflected back and becomes heat in the back of the radio, and that's really not a good scenario. So quite simply here you would have a piece of coax between the radio itself and the transmitter socket of the ATU, and then you would have you could have wire straight in the back of the ATU there. I use a piece of coax from there up to one of these dipole centers that you see on the right, on the left there. The reason I do that is because I can use a PL259 connector on there and tape it up so it's watertight. So what's it all about? Let's get to some technical stuff. So the definition there says, or you can read it, it's a measure of how efficiently the radio frequency power is transmitted from a power source through the transmission line into a load. What does that mean in the real world? It's a measure of how efficiently the radio transmits power through the cabling to the antenna. So you have a table like this which explains it. It looks completely baffling. We're looking at the table on the right hand side, and the perfect SWR is 1:1. So at the top here on the right, let's see if we can have a mouse in this area here. This is 1, and you reference it to something else with a semicolon, so it would say 1:1. And at 1:1, if you look at this power transmitted column, and that's all you really need to look at here, they've very nicely put 100%. Well, guess what? If you're transmitting 100 watts, you can read this as watts. 100 watts will equate to 100 watts going off the antenna. That's pretty good. So if we go down here to 1.5:1, which is a little bit of a mismatch, at 1.5:1, the transmitted power will be 96%, so 96 watts off the antenna, and 4 watts coming back. That's still good. You move it up to say 2:1, and it gets a bit worse. Okay, at 2:1, 89 watts going off the antenna and 11 watts coming back. So now the back of your radio is going to get a bit warm. Take that up to 3:1, and that changes again, 75 watts off the antenna and 25 watts coming back to the radio. Radio's going to get a bit hot because not only is it getting 25 watts back, it's generating that 75 watts. So it's heat sinking the 75, you know, whatever is required to create 75 watts, and it's 25 watts coming back. Any higher than that, you can look yourself on the table here. You know, it's kind of crazy. A 20 to 1 SWR, 18 watts forwards. What would that be? 90, my math's no good. 82 watts coming back. That's not going to happen. The radio's just going to go bang. So that's why it's important. So the setup here is in fact this. It's an ICOM 7300 radio through an ATU similar to this. And then I have, again, the RG58 coax up to the dipole centre and a random length of wire hanging off of that. And my random length is somewhere around about 60 foot. I honestly could not tell you. So the demo in a minute, we'll be using a different ATU to this, but it still has those same 3 dials and the same cross meter. And what we'll be demoing is how you actually tune the antenna. So what we're trying to do is we're trying to match the known 50 ohm radio into a 50 ohm load. So the antenna tuner unit in the middle converts the impedance so that the radio can manage to transmit all its 100 watts and not get anything back. And on the same note, all that 100 watts is going to resonate off the antenna. So what it does is it makes the radio think it's connected to a 50 ohm cable, and it makes the antenna tuning unit convert whatever the unknown is to that 50 ohms. So your signal will go off up the cable through the antenna tuning unit, off up to the antenna, and it will electronically adjust the length of the cable via the inductance and capacitance there. So it changes the impedance so that all of that power will go off the antenna. That's the thoughts of it. Anyway, on to the demonstration. There we go. So what we're going to do, we're going to pick a frequency on 20 meters, and we're going to work out what's the best setting on the ATU to use. Now this particular ATU is overkill and a little bit too complicated. Let's think of it as this ATU, where you just have one set of cross meters and one set of the 3 dials. And if you think of that on here, here are your cross meters and here are your 3 dials. All this is a switch selecting either straight through or 2 different sets of coaxial sockets. By the end of the day, we're going to run one coax through. We've got coax patch lead coming from the back of this radio up into here, and then I have coax going to the outside world, which is about 100 feet away from here. I have RG58 in underground trunking, and it pops up on a short mast, and there's literally just an end-fed piece of wire, so you can say it's a random piece of wire. I don't actually know the length of it. It's somewhere around 60 feet. So that's what's going. So the very first thing we do is on the ICOM radio is we don't tune, we just listen for some background noise. Anyway, obviously on an unused frequency, if you can tell that. But so now we're hearing some background noise. I'll turn it up a little bit, and the 2 dials here we're going to put at the top, just in the middle, and we're going to crank this switch round, a click at a time, and we're going to listen for the volume of the noise on here to go up and down. Now that volume you can also, I'm going to zoom in a little bit here. The volume you can also see is the signal the signal strength here will vary slightly. Anyway, let's crank around. See, if anything, that was a little bit quieter there. There, it's quite quiet there, and the signal's dropped to an S3. It's come right back up there. S3, right back up. So I reckon it's going to zoom back out a little bit. I wonder if we can zoom in on the ATU. There's the 3 we're looking at. It seems to be a bit louder there. I reckon that's the loudest we're going to get in this circuit. Okay, so what we're going to do now is we're going to look at this cross meter. And this needle here, which is pivot point, is down here. It rises with transmit power, and this needle here, whose pivot point is here, it rises with reflected power. Okay, so the name of the game is we want to excuse me, get the old pens out. We're going to try and do this. So it's starting like this. We want to try and do this, kind of move it this way. So this one has the lowest reflective power, and this one has the maximum transmit. So we'll see that quite easy in a moment. So one of the things we have to do here for this, on the radio here, we have to turn the volume off so we can hear. On the radio, we want to keep the transmit power as low as possible in this early stage, because remember, if we stuff 100 watts up the line and 30-40 watts come back, that's really not a good scenario for the back of the radio, and things will go bang. Okay, so you want the minimum power, and you also want a constant carrier, so that could be FM, AM or key down. It's not SSB. SSB is only peaks with your voice. Okay, so what we're going to do is we're going to put this into transmit on the lowest power possible. We're going to monitor these needles whilst rotating these two outside buttons. It's easier to do it together, but you will see. Okay, so we're on a frequency. There's nobody there and nobody nearby. I want to get to power, so RF power, there she is. I'm going to take her right the way down to 0 now. We also need to select the right mode. Okay, so let's assume AM, and let's take that power down 2%. So that's basically, what would that be, 2 watts. So if you get a percentage of wattage coming back from 2 watts, it's not going to be a lot, certainly not enough to hit the rear end of this radio. Okay, so to put her in transmit, you can either tap this transmit button here, or you could use the PTT on the microphone. I prefer the transmit button because it's a one hit and it's on. And at that point we're going to rotate these two knobs. Yeah, let's see what happens. So this needle has risen slightly, that needle's moving, and we can bring the needle down there and up there. That's pretty good. So we're back into receive there, so that's good. Right, now we've got that approximately right. Let's up the transmit power and see what's happening. I'm going to zoom you into this meter. No, well, actually let's zoom into the ATU generally and see if we can get that all on the screen. Okay. Alright, let's see. I have a feeling on this video that you're not going to see the red needles on the meter, so I'm going to zoom in a moment to that, but for now, so you can just see the process, here goes. What I'm actually doing right now is I'm going to turn the power up on the radio to 30 watts, 29 watts even, because this is on the 30 watt setting. I'm hoping this needle is going to go up substantially, and I'm going to press the transmit button. So transmit button pressed. Yes, you see it's way up there, and adjusted that down. There we go, that's really good. She's low, transmits off. So I'm going to zoom in for you so you can see the oh dear, this is going to be nice and big on your screen, I'm sure. Okay, there we go. So I'm going to hit the transmit once just to show you the settings at the moment. So you can see the transmit's right up there, and the reflected power is not even really moving, which tells me it's good. So, okay, now I'm going to rotate the dials on the ATU away a little bit just so that you can see the difference there. See, that's up, that's coming right down, and that's down there. Now I'm going to up the transmit power to 100 watts, and I've changed the position on here to 300 because 100 would go straight off the end on the 30 watt meter. Okay, so here we go. So same thing again, rotate slightly, and there's nothing coming back there. I would be happy to use that. So at this stage, what I would also do, just for peace of mind, is I would note down on a scrap of paper the let's zoom her out. I would note down on a scrap of paper this frequency and the settings on here, which are 1F2. So 1F2 on there, and I'll just scratch them down on a piece of paper, which I actually have a piece of paper here. Know how well that focuses. Let's have a little look. So that's my kind of guideline settings to go back to. So if in the future I want to come on to say 14.220 or somewhere close, I have a starting point. I will whack that 1F3 or whatever I said it was from the scrap of paper. Then I know I'm roughly in the right area, and then I can just twiddle the knobs a little bit to fine tune, and that's it. Yep, she's good. Thanks for watching VA3 SII. Bye.